Okay, so as we're moving along with the chapter and the book, we're probably going to have more and more code to talk about, and hopefully if I give you access to the screen and you can draw to it, it's going to be easier to ask questions. If you have question for a particular line, then you can just point to that line and then you can type your question, or you can just use your microphone and talk about it. But anyway, so you guys can draw on the screen, so that way you guys can get my attention probably much faster. Okay, so let's continue on, and let's see if any of you guys have any kind of a question on any of the chapters so far. Okay, so we talked about that programming languages are really about symbols and reserved words and rules. All right, so that's what the programming languages are about. So last time we talked about that you really need to use Visual Studio and get used to running the sample codes. Running the sample code that came with your book. So as you read the chapter, you run the sample code. If it makes sense to you, then move on, you're done with that chapter. So it's a really good way to start learning. So we talked about the single line comment and the multi-line comments. Right? Commenting is very important in programming. Most of the time, especially when you start out in programming, you're probably just focusing on the code itself. So at this point, what's annoying to you is probably the design aspect of programming, the flow charting, the pseudo code. You know, it's you just want to get your hands on the IDE and start writing code. But think about it like if you build a house and you don't have a blueprint for the house. You can be a really good journeyman, but without a blueprint, you're going to make a lot of mistakes. You probably can build a house, but it's not going to be passing any kind of inspection because you probably built it wrong. So design is very important. Think about the problem. And when you're writing the code, make sure that you comment the code, because sometimes, especially when you get more complicated code, you're going to see that sometimes you understand what you're doing when you're writing the code, and then later on, maybe a year later, you're looking at your own code and you are like, what the heck was I thinking? I have no clue what I was doing here. So the commenting is sometimes it is for yourself. So in this class, the commenting is for yourself, okay? But in real programming, the commenting is for somebody else. So think about it from another programmer point of view. What is the message that you want to get across to another programmer? So it's not just basically that this is, I'm printing out a statement on a screen, but really the message would be something like, or the comment would be, the message is important because we had complaints about not being clear when we're asking for data from the user. So if somebody else is going to maintain your code, usually you write the code and then somebody else maintains it. What is the message you want to get to somebody that will maintain your code? So commenting is very important, and that's what I'm going to be looking for also when I'm grading your assignments. Okay. So the special symbols and basically these tokens that tell the computer what to do, those are just basically operators. But you can see that sometimes we have these double operators, right? When, let's see, when we have a greater or less than sign, the double equal sign, okay? The exclamation point and equal sign. less than equal sign. Okay, those are all considered one single token. So because they are one single token, make sure that you understand that there is no space in between. So there is no space between the two characters. Okay, so they're butting against each other. Reserved words, we cannot use those for our identifiers. So you cannot have int or lowercase as a variable name. And we talked about the basic concept of letters, digits, and underscore characters, that those are the allowed characters, but those characters need to be used in a special way. So we cannot start an identifier with a number, with a digit. We could start the identifier with an underscore, but by convention we are not using underscore as a starting identifier. So C++ is case sensitive, so how you're casing your identifiers will matter. And we have predefined identifiers. So far we talked about the cout. The cout is defined in your IOStream library. So that's why we have to use the preprocessor IOStream in order to have access to cout. And then you need to look at and see if you have any problem understanding these rules and why are these identifiers are illegal. White spaces. So white spaces do not count. They include blanks, tabs, and newline characters, but they do not make any difference when you are writing your code. So let's say you have a code and you're going to write that code, and we're going to say something like if, and we're going to say hello is greater than 15. Okay. Just like with the pseudocode, you indent, and maybe you're going to see out some kind of a message. Okay. So when we are indenting the code, okay, and then we're just going to say cout something else, okay. Now, many times when we get to this point, when we talk about selection statements, you're going to see that indentation is how we show users, other programmers, how the program's supposed to be structured, and it's easier to read. It's nicer to look at. But think about it like a paper that you write. Okay, you have your introduction paragraph, and then you skip a space, indent the first word in the next paragraph. Then you have, let's say, your supporting paragraphs, right? And then you skip a space between each paragraphs. And then you skip a space, and then you write your conclusion. So why would you do that? Why would you skip a space? Somebody can read your paper either way if you just have one big paragraph. So why are we skipping space? It's because it's nicer. It makes the it kind of let the words breathe a little bit, right? We put in some little space in between because it looks better for other humans to read it. Okay. So when we are indenting, later on you're going to see that this indentation does not mean that these two lines of code is in the one block. Okay. So if we don't indent it, the program did not change at all. Or if we over-indent it, the program not going to make it, or we're not going to change the program at all. the white space is going to be ignored. So that means we're only using the white spaces and indentation like we do it in a pseudocode, so humans can understand what belongs where. So in this case, let's say I want to show that the cout hello back to you belongs to the if statement, then I indent it. And the next line does not belong to that if statement, so then I do not indent it. Remember, if you look at chapter 1b, you look at your pseudocode, you would show that exactly the same way, right? So if this would be a pseudocode, we would say if hello is greater than 25, we would just say print, okay, and here we would say print whatever we want to print out, okay. And in the actual pseudocode what we learned, we also need to show where the if statement ends, right? So some of you missed that on the assignment, that you're using the while keyword, you're using the if keyword, but you don't show where the while loop ends or where the if statement ends. So be careful about maybe not getting confused with pseudocode and the actual C++ syntax, because C++ is a little bit different, right? It's not exactly, we cannot just copy and paste the pseudocode. Okay. So data types. Data types is a set of values together with a set of operations. So if you have data types, like an integer data type, you have a set of operations. I'm not sure what you mean by does the pseudocode have a correct syntax. The pseudocode has the correct indentation, but the pseudocode does not have a block that we would need to represent. So let me see if I can look at this. So pseudocode was if A greater than 5, okay, then I want to do a print good, okay, and then maybe I want to do print job, and maybe I want to say print let's say student. Okay. Now the keyword what you use, print or output, they're all the same, right? Remember, pseudocode does not fully have a standard, right? So like here when you say if A greater than 5, you can say at the end of it then, and then you write down all these. So the main thing is it is language specific, language independent, okay? So we're not using a particular programming language, and we're not going to have any kind of syntax that is specific to any programming language. Okay, so let's say here you say else, okay? So when you have the else, okay, so when you have the else statement, you can see that the if statement is at the same level with the else statement, and I'm kind of showing that the three print statement, all three of them needs to be considered if A is greater than 5. Okay? And then we can go and say, let's say print, this is bad, okay? But in the pseudocode, we need to say and if, and that is also at the same level. The print block is indented. If, else, and end if is in the same level. And then you would say, maybe you have a, I don't know, maybe an A block, an A that you want to execute, right? So that's also on the same level with the if statement. So if, else, and if, all that belongs to the basic structure, okay? Now how you do the rest of them, it's as long as you're consistent, you know, I'm not gonna look at it, okay? But the main thing is that we use the indentation. We use the indentation to actually show what belongs to each other. Now, if we want to write this later on, we're going to write this at the actual the actual code. Then we're going to say if A greater than 5, and then we're going to use this curly brackets. Okay. So here we're going to say cout, and we're going to say good, and we're going to say cout. That's going to be job, and then we're going to say cout student. Okay, and then we're going to close the curly bracket, and this is when the indentation doesn't count, right? So you can indent it or not indent it. At this point, it doesn't make sense. In pseudocode, you have to indent it, because you don't have those curly brackets. In C++, the curly bracket shows you kind of like that everything is indented. Consider all this block. So we're going to be basically using this as a block identifier. And then you can say else. Okay? And then we're going to cout bad. Okay? But when I'm using the else statement, the cout I indent, even though C++ is going to ignore it. Okay, so data type. The data types are simple data type, structured data type, or they can be pointers. So what is a simple data type? The simple data types can be integrals. Now remember, in the pseudocode, so far we only said it's a number or it's a string. So we did not really say it is an integer or is it a floating point number. And we still don't have to say that in the pseudocode. We just need to say that I'm considering a number. Let's say that number is going to be held in a variable called age. So we just have to say age is a number. So the pseudocode doesn't specify exactly what kind of a number it is. When you actually writing the code, then you need to figure out, is this supposed to be an integer or is it supposed to be a floating point number? And later on we're going to talk about, and we're going to define, and we're going to know what an enumeration type is. And you guys are going to create your own user-defined data types. But an integral number, right now, you can see that we have the character short integer boolean. That's what you're going to use most of the time. Now we have something called an unsigned, right? So every data type has its unsigned equivalent. So what is this unsigned business? What does that mean? Okay, so let me just see if we can talk about this. Okay. So we have the powers of 2, okay, And I would suggest that you only work with 3 bits at a time and understand basic concepts, right? 2 to the 0, 2 to the first, and 2 squared, okay? So what is the value of 2 to the 0? That's 1. 2 to the first power is 2. 2 to the second power is 4, okay? So if we only have a 3-bit machine, and we need to see the permutation of 3 bits, what are the possible choices? Here, 0 is 3 zeros, so that means 0. 0, 0, 1 means 1. 0, 1, 0 means 2. 0, 1, 1. So what I'm doing is I'm looking at the 1, 2, and 4. And as I'm writing the values, the binary values, I'm kind of adding those to a sum. So 1 is, I see a 1 under 1 and no other value, so it equals to 1. Here I'm looking at 2. 2 has a 1 underneath it, so it equals to 2. Here I'm looking at 1 and 2 has a 1 underneath it, so that is just 3. Okay. So 4 would be 1, 0, 0. That is 4. 5 would be 1, 0, 1. 6 would be 1, 1, 0, because 4 plus 2 is 6. And then we have 1, 1, 1, which is 7. Okay. So this is a permutation of 3 bits. Now if you look at it, computer science is about pattern recognition, right? And if you look at this, you can see that there is a pattern right here in the middle. Okay? When you have exactly 4 values that start with a 0, and you have exactly 4 values that start with a 1. So let's work with let's say 1. Okay? So 1 is 0, 0, 1. Okay? So how does a computer represent a negative number? Now this is not in your book, it's just something extra so you guys can understand what do you mean by unsigned and signed data types. Okay? So hopefully that's going to help you understand it. Now here we have something that's called a 2's complement, and if somebody is more interested in this, you guys can watch YouTube videos. Okay? That's how the computer basically calculates. So what do we need to do? We write down the value, and then we're going to flip the bits. So 1, 1, 0. 0, 0, 1 flipped to 1, 1, 0. And then we add 1 to it. 1 is 0, 0, 1. So at this point, we don't consider the original values anymore. So we have 1, 1, 0 and 0, 0, 1. We add those together. So 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. Okay? So we started with 1. And now, after 2's complement, we came up with 1, 1, 1. 1, 1, 1 will become negative 1. Okay, so let's do that with 2. So 2 is 0, 1, 0. Now let's flip the bits. 1, 0, 1. And add 1 to it. 1, 0, 0. So we don't need to consider the original number anymore. Okay? So let's add those two together. So 1 plus 1 is 2. How do we represent 2? 2 is 1, 0. So you write down the 0, and then you carry the 1. 1 plus 0 plus 0 is 1. And 1 plus 0 is 1. So what we've seen over here as 2, when you apply 2's complement, 1, 1, 0 going to be represented as negative 2. So let's do it with 3. 0, 1, 1 is the value of 3. Binary value, right? We flip the bits, 1, 0, 0, and we add 1 to that. Okay? We don't look at the original number anymore. So 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1. So 3 is not negative 3. Okay? It's kind of interesting to look at, and we can look at the 0 as well. So we have 0, 0, 0. Okay? Flip the bit for zeros. That's all ones. And then we add 1 to that. Okay? 1 plus 1 is 2. So that is write down the 0, carry the 1. 1 plus 1 is 2. Write down the 0, carry the 1. 1 plus 1 is 2. Write down the 0, carry the 1. This is an overflow bit and we ignore it. So what is the 2's complement of 0? It is 0, right? So 0 doesn't change. There's something called a 1's complement. In that case, you're going to have a positive and negative 0. And that was kind of strange to work with, and that's why they came up with this better solution, which is 2's complement. So this way, we're going to have one single 0. And here, the next value is just going to turn to a negative 4 based on 2's complement. Okay? So now you can see if we have 3 bits, right? If we have a 3-bit value, okay, what is the range of values that we can have? If the value is unsigned, okay, unsigned, that means we do not consider signs. That means our range is from 0 through all the way to 7. So with 3 bits, we can represent numbers from 0 through 7. If it is signed, then now our range is split into 2 different groups. So one of them going to be 0 all the way to 3, and then we have negative 1 to negative 4. Okay? So that's what it means basically, that somebody says you have signed values, signed data types. Okay? So where did we have that? Here it is. Okay? So when it says character, you need to look at the character is how many bits. A character is 8 bits. So you have a permutation of 8 bits, and then you split it in half, and now you have a unsigned data type. Or if you consider all 8 bits to a data type, that is a unsigned data type. If it is signed data type, then only half of the bit values are considered for positive, and the other half is considered for negative. Okay, and we show that difference. So if you don't see anything in front of the data types, they are already signed. So you have positive and negative values in it. If you use the keyword unsigned in front of the data type, then you do not consider signed. So it only has positive value, right? So that's what we had over here. This is the unsigned side of our 3-bit data type, and this side is the signed. Signed means you consider the sign of it. So this is when you look at tables like this, right, and you say, let's say a character. Character, you have 8 bits. So you have 2 to the 7th possible combinations of these bits, the 8 bits. So why is that the lowest value is minus 128 and then the highest value is 127? Well, because 2 to the 7th is 256. What's half of 256? 128, right? So when we look at that 128, we're going from 0 to a value. 0 to 3 is 4 values. So if we have 128 values, we're going to go from 0 to 127, right? And then we go to -1. So -1 to a digit that's 1 larger than the highest value of the positive side. And you put a negative sign in front of it. So that's why you see that the character data range is 0 to 127, and then the negative side of it is -1 to -128, because we only have 1 byte. 1 byte is 8-bit. So if you have 4 bytes, you have a lot more numbers that you can represent. But if you look at just the last value, the last digit, okay, you can see that the pattern here, okay, how that works. In order to really make this work or understand it, you just have to understand it with 3 bits, okay. And you can see you have 64-bit in the long, and if you just look at the last digit, right, then that also confirms to what we were doing with just 3 bits. So don't do it with the huge numbers. Understand the simple side of it, and then everything else will fall in the right place. Okay? But that's how you look at this kind of a table. You don't need to remember all the numbers. Remember the rules. Okay? So integer data type does not have a fractional value, right? So because we are saying just int means by default is going to be signed. So because it is signed, you're going to have a positive and negative values associated with that. When you're using the integer, you do not need to use, and you cannot use the comma, the limitation of the 1,000 places. Boolean data type. Boolean data type only has 2 values. But what is the bad thing about Boolean? Look at that. The Boolean uses a whole byte. So the Boolean is representing 2 values. Okay? So you have, let's say, 1 byte. 1 byte is 8 bits. So Boolean false is equals 0, which is 0, 0, 0, 0, 0, 0, 0, 0. Okay? And then you have true. True is 1. And 1 is 0, 0, 0, 0, 0, 0, 0, 1. Okay? You're only representing, or you're only using these 2 bits, and you are wasting 7 bits for this data type, because you're not really using any of that. So sometimes you want to avoid it if you are low on resources where your application is going to be running. If you're running it on desktop these days, we don't really worry about how many bits we lose because we chose a wrong data type. But true programmers that understand what they're doing, they're always going to be selecting data types based on what they need and on what device that application is going to be running on. Okay, so character data type. Now the character data type is really a character encoded. Okay, so when you see a character, that character is really a integer data type or integral data type. Okay, so if you look at it, right, you can see that the character, and then you have the unsigned character, is part of the integral. So how can that be? How can a character be an integral type? How can it be a number? Okay, and that's when you can look at it and look at the ASCII table, okay, the ASCII character set. So your computer does not understand characters. The computer understands numbers. Oops, what happened? Is that going to come up? Okay, let's look at it and see. Okay, so make sure that you spend some time on these tables right here. Okay, so we have two tables. And one of them is the ASCII character set, and the other one is going to be the extended ASCII character set. But if you look at it, okay, you have 0 through 9, and those actually mean a number. So when the computer sees 48, 48 means 0, character 0 to the computer. So if the computer sees 65, it means character A. And that's why it displays character A, even though it is still calculating the number. Okay? So the numbers, okay, so the characters are numbers. So this character is, you have to specify the single quotation marks. The single quotation marks makes it a character, but when the computer stores it, it will store the decimal 65 or hexadecimal 41 for that particular character. And that's why we are able to look at it as a number. And that's how later on we're going to be able to compare numbers, or compare letters, and compare strings of information, because we're really going to be comparing the number value for these characters. So the blank space is also a character. And I don't know if you ever downloaded something from the internet, but let's say if you would download Richland College, right? Richland, you would have a %20 college. I don't know if you've seen that. Let's say it's a text file. Okay. I don't know if you've seen that when you downloaded something from the internet, and it was saying %20 in between, where there was supposed to be a space between words. Now that also comes because of the ASCII characters, right? So so if you look at it, right, 20 is a space, which would be decimal 32. Okay. So so you can really understand a lot more about computers and how computers work if you learn about, you know, technology, what we're doing right now. So now it would make sense when a lot of %20s come up, and you would say, hey, I know that. It's because that's the ASCII character number representation for the space. Okay. So why can we compare, let's say, characters? Let's say A and B. So the alphabet is an ordered list. You can see A is 65 and B is 66. So that means A comes before B. So that means A is less than B. And that's exactly how you would think if you would work in a library and you would need to put books on the shelves. You would think exactly the same way as you are alphabetizing the books. You would put the A books first, and then you would put the titles that start with B. Now what about uppercase and lowercase? Right? You can see that uppercase comes first, and then lowercase follows. So we can even look at uppercase A and lowercase a, which one comes first. If you understand this ASCII table, then you can answer questions on quizzes and exams, because you really start thinking about this whole concept of ordered lists and how computers order values. Now if you look at this table, right now you need to look at the pattern. What is the pattern here? There's an ordered list of numbers comes first. Then the capital letters in the alphabet comes next. And the third group, what we can easily identify, is the lowercase characters, and that comes third. So number is less, any number is less than any character. Okay? An uppercase character can be either greater than a number or less than lowercase character. Lowercase character is always going to be greater than uppercase character or a number. Okay? So then, again, it's going to be easier to remember if you remember it from a pattern point of view and not looking at every single individual item in here. Okay? So, if you look at the ASCII table, okay, one interesting thing about the ASCII table is that you have only 128 values. So what is that 128 value? Well, the 128 value, if you look at the values, they're going to be from 0 to 127. So what is 0? 0 is 1, 2, 3, 4, 5, 6, 7, 8 zeros. And what is that 127? 127 in binary is 0, 1, 1, 1, 1, 1, 1, 1. 7 ones and the 0. So now you can see that the most significant bit in the 8-bit sequence is not used at all. So ASCII is not using the most significant bit. Okay. Now, if you look at the extended ASCII, again, you can Google it and look at the extended ASCII. Extended ASCII is using character values from 128 to 255. Okay. So what is 128? 128 is 1, 2, 3, 4, 5, 6, 7, 8. So you can see that the most significant bit is set 1. Everything else is 0. And what is 255? 255 is all the bits set to 1. So now you can see that we have all the bits set to 1. Okay. So ASCII is maybe just call it the US, the English-based character sets. Okay. So extended ASCII, you would think about the German, you would think about maybe Spanish, when they have those strange diacritics, right? So they have and they have or 2 dots on top of. Okay, we don't have in English. You don't have enough bits. You don't have enough bits with 7 bits to represent these characters. So they designed and they used the 8-bit, and with the 8-bit now you doubled the characters that you can represent, and now you can basically use different languages. Now, if you're thinking about Asian languages have even more. They have hundreds of characters. So 8-bit is not going to be enough. So with Asian languages, what you have is two bytes to a character. Okay. So you have 2 bytes to a character, and what we call is Unicode. Okay, that's going to be the Unicode. So you have 8 bits and 8 bits. So a Unicode character is always going to be 16 bits to a character. Okay. So that's the data types, the basics of these really data types. ASCII code. Look at the ASCII table. It's going to make a lot more sense, especially if you're practicing taking a decimal or hexadecimal value and converting it to a binary value, and you write it down. Then you're going to see all these interesting patterns that will emerge. So floating point data type. Now these are real numbers that you're going to have fractional values within the value. So so you can represent these values differently than we represent the integer, and we're going to have different problems associated with floating point values. One of the problem with floating point value, right? If what if you are dividing, let's say, 10 by 3? What's going to be the value of that? Well, 10 by 3 is 3.33333. It's an infinite number. So if you need to consider fractional values in a number, sometimes they're going to be infinite. And if they're going to be infinite, how can a computer know how to calculate with it? So the computer, when you're working with floating point values, the computer is going to have to estimate and round values. So with floating point values, we're going to have a problem of rounding errors. So as far as this book is concerned and the author is concerned, when we're using floating point values, we're going to be using only double, because double is going to give you double digit precision. So it's going to be more exact than floating point, just float data types. So we have in the floating point data types, we have float or double. So you can see that a float represents or saved or uses 4 bytes, while double uses 8 bytes. So you can, in 8 bytes, you can put a lot more precise value in it than in 4 bytes. So you're going to have a lot less rounding error in double data type than in the float data type. But what is the backdraw of that? Well, the backdraw is that we're going to use a lot of resources, because you use twice as much memory to store a number. So if you want to store somebody's age, you probably do not want to store it in double. Why would you use 8 bytes to store something that's never going to be more than maybe 120, right? So 120, we can represent 120 with maybe just the character data type, okay, or maybe a short. Short only uses 2 bytes. So that's why you need to understand how many bytes are associated with what data type, so you can make a better decision when you write your code. And that's not going to be in a pseudocode. Now, this is specific to the language. So in a pseudocode, we only said number. But now we need to make a better decision, a specific decision to our code, which data type we're going to actually use. So the float data type is also called a single precision, and the double data type called double precision. So float can have 6 to 7 significant digits in the decimal places, while double can have 15. So it is more precise. Okay. So in order to declare a variable, you must specify the data type. So C++ is called a strongly typed programming language. That means when you are defining a variable, at the definition, you have to say the data type for that. So if you say int counter, right, because int is taking up how many bytes? Int is 4 bytes, right? So somewhere in memory, the operating system needs to find 4 bytes, okay? And now the counter is pointing to those 4 bytes. And then you can associate some values with this. We can now initialize the data type. Right now we are just declaring them. So when we're talking about double, right? Double, now you have to look at, and the operating system needs to find not 4 bytes, but now we need to find 8 continuous bytes in order to store the interest rate into it. So now if you have character, the operating system needs to find just 1 byte. Okay. So your grade, if your grade never going to be larger than 100, it fits into 8 bytes. I mean 8 bits. Why? Because if we would use, let's say, 100, the positive value of a character is 0 through 127, so 100 fits into that. Now, what if your grade is 200? Okay, 200 will not fit into 8 bits because by default, character is not, the character is signed. Okay, so how can we fix that? How can we still use 8 bits to use store 200 in it? We can say unsigned in front of it, and now we're using the full capacity of 8 bits, which can store 0 to 255 to 256 characters. So now 200 can be stored in that. Okay, and that's why it's important to understand data type and how many bytes each data type is associated with. So here we declared variables, and now because we have the interest rate declared, now we can use the assignment operator to store the value in the memory location. Arithmetic operators, precedence, and the expression. Okay, so we have the arithmetic operators, and here, just like in elementary school, we learn the order of precedence. Gonna be important to understand. Probably that's when you want to spend a little more time on when you are reading this chapter, right? And probably the modulus operator is what most people less familiar with. You want to spend a little bit more time on that. Okay. So an arithmetic expression contains values and arithmetic operators. Operands are the number or value of which the operators will work. Now, those operands can be variables, right? So we can say if A and B are integer data types, then we can say A plus B, because we mean the value of A plus the value of B, whatever will be stored in there. Operators can be unary or binary. So unary operators will need only one operand, while binary operators need 2 operands. So in this case, if you have, let's say, you're just saying -2, right? That's perfectly legal. That's perfectly fine, because in this case, negative is a unary operator. Now here, if you say, let's say, A equals 4, and then you say A minus 3, in this case, minus sign is a binary operator where you have one side of the expression and the other side of the expression. Okay. Here, we only had one side of the expression. So a dash can be either considered a negative sign or it can be a subtraction. Order of precedence, this is when you kind of look at the, what is it called, PEMDAS, right? So you say, please do, or no, what was it? Let's see, what is it called? Please excuse, right? Please excuse my dear Aunt Sally, right? So we have the parentheses. Parentheses take over everybody else, okay? And then you have the exponent. So if you need to raise a number to a power, you're gonna do that before you do multiplication. And you have the division, and then you have the we have the multiplication, we have the division, we had the addition, and then the subtraction. Okay, So what is it that you perform first? Okay, when you see a arithmetic expression, right, be evaluating it from left to right. Okay, and you can see that there is a parentheses. So because you see the parentheses will take over. Okay, how do I get rid of this? Okay. Okay. So if we don't have parentheses, what comes first? Okay. First comes the multiplication. Okay. So you're going to do a multiplication. 3 times 7 is 21, right? 2 times 5 is 10. And then you scan through and then you say, oh, okay, we have a division. Okay. So now we can divide 10 by 4. Now this is going to be interesting because we have two integers. We're going to call that an integer division. So 10 divided by 4, integer division, going to result of 2. Okay. And then you look at what comes next. So we have the addition. So this is gone right here. So that means 6 plus 2 is 8. 8 plus 6 is 14. And now you do the subtraction. So it's going to be 21 minus 14. Okay, it's going to be 7. So then you look at the expression with the parentheses. So now you have to, the parentheses take over. So we have a parentheses right here. So it starts, the parentheses starts right here. And that parentheses ends over here. So the very last operation we're going to do is the addition. Then you go inside the parentheses, and then again you are evaluating it from left to right. So this is the parentheses that I see. So we need to evaluate, we need to look at the parentheses. So within the parentheses, we need to look at that, and this is the operation. So we need to perform that. When we perform that, we come out of the parentheses, this inner parentheses, we have to perform the subtraction. So with that subtraction, that's going to be 15, right? And then we look at the next operators. We have a plus sign and the plus sign, but then we have the parentheses. So we need to go inside and you do the multiplication. So that's going to be 10, and then we divide it by 4. It's going to be 2. Okay, and then now we have 15 plus 2 plus 6. Okay, this is going to be 23. So you might get different result because of the order of precedence for these different operators. So you need to be careful with those. Okay, so make sure that you spend time on the integral expression. Integral expression, all operands are integers. The result is going to be an integer. No fractional values considered. Okay, a floating point expression or a mixed expression will always result of a floating point value. Okay. So if you are, let's say, dividing 5 by 9, it's always going to be 0. But if I divide 5 by 9.2, okay, it's going to be 0.4 something, right? So it's almost going to be half. But because we have a integer with an integer divided, and here we have the integer and the floating point, the result will be floating point value. So be careful with that. Okay. Now with the type conversion, okay, what you can do is, let's say we have a code, and within the code we're going to say, I have a data type called character, and character, I'm going to call it me, character me is A. Now if I want to print this out, if I'm going to print out C out me, what's going to be printed out? What's going to be showing up on the screen is A. But maybe that's not what I want. I want to see what is the number value, the ASCII code value for A. So then we can do C out static cast. What is it that I want to convert it to? So I want to see integer. Oops. We need to use the brackets. Okay. And then we need to use what is it that I want to convert. So what I want to convert temporarily is the variable me. Me is a character data type, but I want you to consider it as an integer. So then on the screen when we print this out, not A going to be showing up, but it's actually going to show up 65, because the integer value of A, and that's what me holds right now, me holds A, the integer value of capital A is 65. So static cast can temporarily change what is it that you're considering as a data type for the variable. Okay. So again, you have this example 2-9. So you need to open it up in Visual Studio, run it, and it's going to make a lot more sense than just reading about it. Okay. If you're not using a compiler, you're probably not going to understand much about any of these chapters, what we're talking about. So string data type. String data type is not a simple data type. Now it's going to be a more complex data type. But in a string, you have individual characters. So these individual characters are combined into a string. So each individual characters are still going to be ASCII characters, but now we are combining it into a string. And that's why in this case you can see that the string has a length, but since we talked about that the space is also an ASCII character, when we consider the length of the string, you're not just considering the printable strings, but every single placeholder within that string. So in this case, the length of string is 13. Okay. So when we are assigning variables, data must be loaded into main memory before it can be manipulated. So storing the data into memory is a two-step process. We need to instruct the computer to allocate memory. That's when we told what data type we have. So how much memory to allocate? 1 byte, 2 bytes, 4 bytes, 8 bytes. And then include the statement to put data into it. So how do we put data into it? Well, we can use the assignment operator, the equal sign, or we can read from, let's say, the keyboard. Okay. So if you have a named constant, the named constant is just using the keyword const. The const will make sure that the data type that represents that identifier cannot be changed at runtime. So let's say the text values, right? So if every item in your shopping bag needs to have 8.5% added to that, the 8.5% would be a constant. Now each item's price would be just an identifier, a variable. But the text doesn't change that often. So you would really keep the text as a constant value. Okay? And that's just basically the only thing that you have to do is put the const in front of the variable. Okay? If you don't use the constant in front of it, it's going to be changeable at runtime. If we use const, after we run the program, we cannot change it. Another thing that you might need to look at is constant values, constant identifiers use all capital letters. So that's how you look at, you can find out just by reading the name of the identifier. If it's all capitalized, we know it's a constant value. Okay. So how do we put data into variables? Okay. We can have the assignment, so we do the equal sign, and that's pretty obvious, right? We evaluating the expression, we look at the expression, and then we assigning it from right to left. So if you have an expression, it needs to be calculated first, and then the equal sign is considered. Okay. So first you need to declare the variables and then you initialize it, right? So then you have this whole idea of input statements, right? So the input statements, just using the CIN. Where CIN comes from? CIN is coming from a preprocessor. It's a predefined variable that is defined in your IO string. Now we have the stream extraction operator, and then what variable we are reading into. Okay, and that's pretty much all how you need to use CIN. So we can have in one statement we can have multiple reads. In this case, the user just needs to type in, let's say 5 space and then 15. So CIN will look at, this is kind of like a bus. Okay, all these values are sitting on a bus as individual characters. Okay. So CIN will read and say, okay, I have 5 coming in. What do I do with that? I need to store it in feet. And it will stop reading when it sees an empty space. So then it says, okay, I need to store another value into this variable. So it starts reading 1, 5, hits the space. So then it takes 1, 5 and assigns 15 to this, while feet had 5. And we do all that in one single line, one single statement. Okay. Again, make sure that you do run this this code that comes with your book. Okay, and it's going to make a lot more sense. So you have the output statement, and then we have the input statement, and then the output statement. So how can the CIN figure out what kind of value you're typing in? Well, CIN knows how to read it because you already told the variables what data type they are. And based on the data type, it knows how to read it. Okay, so make sure that you run that code. Okay. Now, when you're talking about pre-increment or post-increment, or pre-decrement or post-decrement, okay, this is the same thing as if you say x equals 5, and then whatever we do, before we deal with that, add 1 to x. So that means x equals x plus 1, and then y equals x. So what's going to be the value of y? Value of y is going to be 6, right? So we had 5, but before we used the assignment operator, before we used that, we incremented the value of x by 1, and that's going to be 6. Now, if it's a post-increment, what does that mean? If we have x equals 5, then y equals x, and then x equals x plus 1. So in that case, here, y going to have 5 in it. In this case, y going to have 6 in it. Okay? So the assignment operator comes last. Output. The stream insertion operator is kind of like the extraction operator, okay? But you're using it with the cout predefined variable. At this point, just focus on the expressions. Later on, we'll learn what a mutator is, okay? But right now, it's just the expression, okay? So cout, we have a literal string. Here, cout, and we have an expression, okay? And let's see, we don't have one that has a variable, okay? But you can see that here we have the actual literal string, and then right after the literal string, we are printing out the value of the expression. Again, make sure you run that. Okay. Escape sequences, those are going to be very important. So this table is important for you guys to look at. Okay. So right now, let's say if you're using cout, what you do is you say hello ENDL, right? What does that do? It prints out hello, and then at the end it adds the carriage return. So what else can we do? We could just say cout, and in the string we can say hello \n and just terminate the statement. What does that do? It still prints out hello, but instead of using ENDL modifier, okay, what we're doing is we are adding the new line character to the string itself. So this \, has a special meaning when the n follows it. So then the question comes out, what if I need to print out hello \me? Well, in this case, if I have to print out one single \, you need to double it. So you need to have two \. Okay? That's why it's called the escape sequence. We're escaping the meaning, the regular meaning of the character. So if you put a \, in front of the single quote, it will print out the single quote. Okay? If you put a \, in front of T, it will actually press a tab or print out a tab character on the screen. Okay? So C++ by itself has small number of operations. So how do we extend that? We extend it with the preprocessor. Okay? And this is the generic syntax, and all of our code, all of our examples, all use the hash mark included IO string. Okay? So we covered that on Monday. So we talked about the namespace, right? Think about the namespace as a box. Okay? String is not part of IO string and is not part of just a regular C++ language. So you need to include the library in order to use strings. And then you have the basic structure of the main program. So we also covered that. Okay. The source code is a CPP file. So that's the only thing you're going to have to submit when you submit your assignment. No object file, no executable, no exe file extension. Only thing that you're going to have in your assignments is your flowcharts and your CPP files, your source code. So you need to know where you're storing those. You need to know where you save them. You need to know how you name those CPP files. Error messages, make sure that you keep reading the error messages, because the error message will give you a really good indication where your problem is. So right now you have a line number 9 and on line number 11 you have a problem. There's a syntax error, right? So what's the problem? You're missing a semicolon, so you were not terminating the the line prior to this particular line properly. Okay, so then you have a problem on line 11, and seems like you're using temp num variable, but it is undeclared. So you're trying to assign, so you're probably using something like temp num equals 5, but you never said int temp num. Okay, that's just a semicolon right here. So it's never been declared, so you cannot assign anything to it because the compiler doesn't know what data type it is. Okay. So using of blanks is just for readers. Okay. All the statements end with a statement terminator or the semicolon. Okay. So the brackets are not statements, and those are delimiters. So those are going to be our block delimiters. We're going to specify blocks with those. Okay. Semantic rules. You need to be careful because it is not a syntax error. So logically, you have to know operator precedence in this case to figure out where you made the mistake. So last time we talked about it, you have to test your code after you're done with it in order to find these kind of mistakes. Okay. So how do you name variables? We learned that in prior sections. You need to think about self-documenting identifiers, something that centimeters per inch. You don't need to have a comment what that variable going to hold, because it just tells you by itself, just by the naming of the variable, what is it that you're holding in it. Okay. So what we use is this style, right? Mainly what we're going to use is this, which we call the camel casing. Okay. If you like the spaces in between words, it's just easier for you to read. That's perfectly fine, long as you're consistent with it. Then, since space is not allowed in identifiers, what we can have the underscore. But make sure that you are consistent. Okay. We need to have prompt lines so the user will know what to type in. Documentation is crucial. Okay. Think about your form and your style. How do you write your code? So this one is easy to read, right? So I can see that there's an integer data type and two integer data type are declared. Here we have a double data type, two double data types declared. Here you have an integer, and here's the end of the statement. So there are two variables declared as integer data type, and then I have to notice that after the semicolon there's another data type, and now I have double X and Y. So I would say don't use this. Okay, this one is the proper way of using or developing your style of programming. Okay, and there are some shorthands or compound statements. So X equals X times Y can also be shorthanded as X times equals Y. So it's the same thing. So we have these compound operators that we can use in our code. Okay, but that's basically all this chapter is about. It's only going to make sense if you run it in Visual Studio. Okay, so if you don't run all the sample code that comes with your book, you're going to have a hard time understanding what that does, especially if you have not programmed before. Okay, so the concept is not hard, but you have to run it. You have to do it yourself, and you have to run the actual code. Okay. Sorry, we ran a little bit too late this time, but hopefully it helped you understand this chapter. And so you guys have an assignment due today, and then you also have to do your test 2. So make sure that you review this chapter 2, you work on the assignment, you work on the chapter review quizzes before you attempt the actual test. Okay? So I'll see you guys on Monday, and make sure to use the discussion board and bring in some questions if you have any. Okay? Bye.